You know that feeling when you're using an AI chatbot and you're just waiting and waiting for it to finish typing out a long answer? And you just think, come on, why is this so slow? Well, you're not alone, and a groundbreaking new paper might have just found the answer. And trust me, it could completely change the future of AI.
Right, it's a frustration we've all felt. You ask this really complex question, and the AI starts generating its response word by word, agonizing word. But why? Why does it have to be this way? Well, to really get why the new solution is so brilliant, we first have to understand the problem.
Okay, so let's dive right in. The reason for this slowness, it turns out, is a fundamental speed limit that's baked into almost every single large language model out there today. Researchers have a name for it, the token-by-token bottleneck.
So here's the thing. Right now, AI doesn't think in sentences or paragraphs the way we do. It thinks in something called tokens. You can think of a token as basically a word, or even just a piece of a word. And it generates your entire answer one single token at a time in a long sequential chain. This whole process is just incredibly repetitive. The model writes one word, then it has to stop, reread everything it just wrote, plus your original prompt, and only then does it figure out what the very next word should be. Imagine trying to send a long text message using Morse code, one letter at a time. It's just fundamentally inefficient. But what if AI could break free from this one word at a time trap? This new paper proposes a pretty radical shift in how we approach this whole thing, moving from thinking in these separate, discrete words to thinking in continuous ideas. And this, right here, illustrates the difference perfectly. The way we do it now is slow and has what's called low semantic bandwidth. Think of it like trying to get water through a tiny straw. Only a little bit of information can get through at once. But this new method? It's designed to be holistic, fast, with high semantic bandwidth. It's like switching from that straw to a massive fire hose, allowing it to blast through entire concepts all at once.
The researchers really put it perfectly themselves. The goal here isn't just about making the old process a little bit faster. It's about changing the game entirely by packing way more meaning into every single step the AI takes. So the crucial question is, how on earth do they do it?
All right, so how does this new method actually work under the hood? Let's take a look. The solution involves teaching the AI to stop thinking in words and start thinking in something much more compact and much more powerful, vectors.
And the name for this new approach is CALM, which stands for Continuous Autoregressive Language Models. The name itself gives us a huge clue. It's all about moving from that choppy, discrete world of tokens to a smooth, continuous world of ideas. The real magic behind CALM is this component called an autoencoder. The easiest way to think of it is like a zip file for language. It takes a whole chunk of text, we're talking several sentences at once, and compresses it all down into a single dense package called a vector. The AI then learns to predict the next vector, not the next word. It's a total game changer.
Now, you might be thinking, okay, if you're zipping and unzipping language like that, surely you're going to lose some information, right? There must be errors. But what is truly remarkable is the fidelity here. The autoencoder can reconstruct the original text with over 99.9% accuracy. That's not just a theoretical concept. That's incredibly robust. It just works. So this is all fascinating in theory, but here's the million-dollar question. Does it actually lead to a real-world breakthrough in efficiency? Well, the results are in. And yeah, they are extremely promising. The core finding of the entire paper is that CALM just dramatically improves the trade-off between performance and the computational cost it takes to get there. In other words, it can do way more with way less.
This chart just makes the benefit crystal clear. Look at that. To reach the same level of performance as a really strong standard model, CALM requires significantly less computational power. Because it's generating entire concepts at once, it simply has to take fewer steps, and that saves immense amounts of energy and time.
So let's zoom out for a second. What does a breakthrough like this really mean for the future? Because this isn't just some small, incremental improvement. This could be the start of a whole new chapter for how AI is developed.
Just as the paper concludes, this approach represents a powerful and, this is the key part, scalable pathway toward building ultra-efficient language models. This could be the key that unlocks that next level of AI capabilities we've all been waiting for. So if you remember just one thing from all of this, let it be this. Shifting from predicting the next word to predicting the next vector allows AI to think in concepts. And that simple but really profound change is paving the way for models that are not just faster, but fundamentally more efficient and more powerful.
And that really leaves us with a fascinating final question to chew on. When our AI tools can generate and connect entire ideas in a single step, what new applications, what creative breakthroughs, what incredible new forms of intelligence will suddenly become possible? The future is continuous, and it looks like it's arriving a lot faster than we think.